In this question, we consider what happens if a part of a definite integral becomes infinite. In this first part, we have a boundary of infinity. Keep in mind that it could also be negative infinity on the other side, but we'll be doing the same thing. We'll be replacing the infinite limit with a finite value, such as a. We have a boundary between 7 and infinity, and we have a function of 5 over x squared. We're going to rewrite our function to make it easier to calculate and also replace infinity with an unknown value, such as x, or a in this case. So once you've integrated it, we can now plug in our two limits of a and 7. And from there, you see, we're taking the limit towards infinity, provided the limit exists. We'll simplify this now, and so we'll end up with our 5 over a. As our finite value, a, tends to infinity, our calculated integral with the upper limit or lower limit tends to 0. 5 over a tends to 0, so the answer will be 5 over 7. For the next example, we're looking at improper integrals where the function is not defined at one end of the interval. So in this case, we have a 18, well, from 0 to 18. So we replace the 0 with a, like we did in the previous one. So just rewriting and then calculating the integral. So once we've done that, we can again, just like the previous question, plug in our values, or our boundaries were 18 and a. Remember that our function of 2 over root x is not defined when x is equal to 0. We take our limit as a tends towards 0, so 4 to the root a tends towards 0. So our limit there, 12 to the root 2 minus 4 to the root a. So we end up again with 4 to the root a is equal to 0. So 12 to the root 2 is our final answer. For future reference, just remember what an improper integral would look like. Consider that a part of it, or a part of the definite integral, becomes infinite. And also think about the fact that it could be approaching an infinite value, or approaching positive or negative infinity at either or both ends in the interval of integration.